Welcome back to the channel. As you might know, we are in a series where we every day we pick an interview experience from lead code and try to solve all the interesting questions from that. Not only that, we also try to solve all the possible follow-ups of that particular question. So if you are interested, you can check out different playlists that is linked in the video description below. Yesterday, we pick up an interview experience of Microsoft SDE2, and we solved the second question of that. And we also solved some nice follow-ups of this question. I gave some follow-ups as an exercise to you guys yesterday. So in case you haven't watched the previous video, I will strongly encourage to watch that video and come back here so that you have into an understanding of what we have discussed and where we are coming from. Today, I will be discussing all the follow-ups that I have given an exercise in the previous video, as well as some other interesting follow-ups of this question. So this question is very great question because it has a lot of follow-ups. So we will be discussing at least three of them today. So let's start. So just to recap, what is the question? The question states that are like we are given some n number of employees. Each employee gives their availability. So this list states that basically 0th employee is available on day 0, day 3, and day 9 to take a course. So we are also given this total number of days, which denotes uh, the number of days in which we can schedule the course. And we are also given repetitions, which denotes number of times the course can be scheduled among these D days. So let's take an example. Let's say the total days is 10 and number of repetitions is 2. It means we can schedule the course 2 times among days 0 to 9. So for example, if we select day 3 and 4, and we can see 0th employee can attend because he or she is available on day 3. Similarly, employee with ID 1 can attend, employee with ID 2 can attend because uh, of availability of day on day 4. Employee with ID 3 can also attend, employee with ID 4 can also attend because of availability on day 3 or day 4. But employee with ID 5 can't attend because he or she is neither available on day 3 nor available on day 4. So that's where there are total 5 employees that can attend the course, uh, and that's the maximum possible number of employees that we can get. So given these availability and number of days as 10 and total repetitions as 2, this is the answer that we will come up with. So yesterday we discussed some solutions, and finally we ended up in a solution which is of time complexity order of d factorial, where d is total number of days. So just to recap on the solution, so what we have discussed yesterday is this solution. Basically, we have defined a recursive function f of dr, which denotes the possible ways to schedule the course r times in 0 to d days. So basically, it will return a vector of vector. The inner vector is will be of size r. So basically, this will denote possible days of possible days among these 0 to d days of scheduling the course r number of times. So for so we have come up with this recursive function with basically we are saying if there are, let's say, d days, uh, then we are trying to fix what will happen on day d. So let's say this is the day d. So what will happen on day d? Either we will schedule the course or we will not schedule the course. In case we schedule the course, then we will be left with total d minus 1 days, and because we have already scheduled the course one time, so total number of possible scheduling is d minus 1 r minus 1. And in the second case where we don't schedule the course, basically we will be left with d minus 1 days to schedule remaining courses, and we have total r times that we can schedule because we haven't scheduled any of the course, any of the days before. So that's what the recursive function is, and we calculate this vector from there. So just to recap on the solution, this is what we have looked at. uh, we have we have find all the possible combinations of this scheduling this course this many number of times in 0 to d minus 1 days. And this function is quite simple, like that just we have discussed that part. We have, like, either we will take the current day or we don't take the current day. And once we get all the possible days, we will iterate over all this selected days possibility, and we will see for each employee whether they are available on that particular whether they are available on any of these days, any of these selected days. If they are available, we will increment the employee count. After this loop, then unique employees will contain all the employees who are available on one of these selected days, and we will just take the max over all such possible cases. So that's what we have ended with yesterday. Now we have also discussed one interesting follow up wherein we have tried to reduce the space complexity of the problem. So if you look at this again, we are taking this vector, we are building this vector from scratch, and this vector will contain all possible combinations. So our time complexity is d factorial, but our space complexity is also d factorial. So that's where we come up with this solution wherein we are saying that f of d comma r comma selected days will denote what is the maximum attendance possible if all the days in selected days are already selected, and we have to select r, like we can schedule r mode, and we can schedule the course r more number of times among this remaining d days. So that's what our new state was. And just to recap, that's what that's how the solution will look like. So if you haven't solved it yesterday yourself, you can watch this part. So basically, as we have discussed, we have this current day repetitions left and selected days. So if repetition left is 0, we will just return the number of employees available on this list of selected days. And let's just forget about other base cases. So we are doing again the two things: either we can take the current day or we don't take the current day. If we take the current day, the new selected days will become selected days plus the current day, and we will just ask for maximum employee attendance from remaining d minus 1 days, and number of repetitions will be one less because we have already selected one day, and the number of days that we have selected will be denoted by this new vector, new selected days. So the second possibility is we don't take the current day. In that case, we just like this is the previous selected days, we will just pass it as it is, and we still have this many repetitions left, and we have total d minus 1 left to schedule the course this many number of times. So that's what the solution was. Number of employees available is very straightforward, like whatever we have been doing previously in the actual function. Like in this function we are now doing in a different function, that's it. So now they, like with this solution, do you see there like is there any pre-computation that is like that you can do to save some computations? So basically what I'm saying is, uh, so currently f of dr and selected days denotes this particular thing. Now let's say number of total days that we have is 4. So these selected days will, like these selected days can be any of these 4 values, like 0, 1, 2, 3. Now basically we could have memoized this entire thing, like because we can see some computations are happening again and again. So we could have memoized this, but because this is a vector, what you will put as the third parameter. So whenever you define this, let's say you define this dp array, so the first will be current day, that's fine. Second will be this repetitions left, that's also fine. What will be the third argument? So you can't put this vector here, right? you have to put an integer there. So that's where what we are saying is, let's convert this entire vector to an integer so that we can memorize the previous solution. So this solution is still order of d factorial, but if we can memorize it, we can easily bring down the complexity a lot. So we have this vector and we want to convert this to a integer. So the best way to convert this is to represent this integer somehow in binary. So for example, let's say we have 4 days. So this is the 4 days. Let's denote this by 0, this by 1, this by 2, and this by 3. Now when we are saying that we have selected day 2, so initially everything is 0. 0 means we haven't selected day 3, day 2, day 1, and day 0. Now, or let me just write with a different color. So initially everything is 0. So 0 means we haven't selected day 3, day 2, neither day 1 nor day 0. Now, let's say we selected day 0. In that case, we will just um, replace this 0 with 1. So previously, the binary, like the decimal representation of this binary was 0. But after replacing this with 1, the decimal representation of this particular binary 0110, uh, this binary, the decimal representation of this binary is now 4. So basically what we are doing is we are taking a vector and we are converting it to an integer. The integer is basically the decimal representation of the binary vector. So this vector, instead of saying that the selected days contain 2, 3, 2, 3, 1, we will say that this selected day uh, contains entire d days. Everything is 0 initially, and as and when we are selecting some day, we will just make this to 1. Now because this is a sequence of zeros and ones, we convert this sequence of zeros and ones to its corresponding decimal representation. We consider this as a binary, and we convert this to a decimal representation. So just for one more example, if let's say we have selected day 2 and day 3, so in that case the selected day array will look like something this. So basically this is the selected day array with 4 binaries. Now because we are like converting this, like we can just assume that it is a binary representation of some number. So we will just convert this to its corresponding decimal representation, which will be 4 plus uh, 4 plus 8, 12. So that's the decimal, like the decimal representation. So hope you got the intuition how we are converting this vector to an integer. So why we are converting this vector to an integer? Because we want to memorize this solution, and for memorizing we need the third parameter to be a integer. So that's where we are converting this vector to an integer using something like this. So we are saying that we will not store the actual days. Instead we will store a binary vector. Initially everyone is 0, whichever days we select. So if the vector, if we select 2, 3, and 1, then corresponding value in this vector will be once others are 0, and then we will convert this entire thing to its corresponding binary representation. So let's look at the solution now. So as discussed, what we have done, like previously we have current day repetitions left, and this selected day mask. So let's just look at the pseudocode. So first, so basically this will be the pseudocode. We have three things now: d, r, and mask. Previously this mask was nothing but the vector. Okay, so now we are doing the same thing. We are saying that if we select this dth day, we will just append these to the selected days vector. But now the way we are appending is little bit different. So previously we are just appending this current day to the vector. So if you remember, we are just appending this current day to the vector. But now, because this is not a vector, we are saying that the uh, corresponding value will be set to 1. So basically dth day will be set to 1 here. So how to set the dth there? Let's say you want to set the second bit. So how you will set the second bit? Second bit is nothing but 2 to the power 2, right? So that's where we are just performing an OR. So if you know binary operations, OR denotes like if OR basically means 0 or 1 is equals to 1, 0 or 0 is equals to 0. So like if any one of them is 1, it will be 1. So 1 or 0 is 1, and 1 or 1 is also 1. So that's the basic OR operations. Now what we are doing previously, whatever bit was set, we respect that and we set this bit. So this mask, new integer will denote whatever days we have set it previously plus this day. Now with D is this, and without D is simply we haven't changed anything to the mask. Whatever we have, we just pass it as it is. And at the end, we'll just take the maximum of with and without D. So that's what exactly we are doing. We have this selected days mask. If repetition step is 0, like we have selected all the days, then we will just return the number of employees available with the selected on the selected days mask. Otherwise, we will either take the current day. If we take the current day, number of repetitions left will be decreased by 1, and we will just update that particular bit in that array. If we don't take the current day, we will just pass the previous mask. And if you notice, we have now memoized it. Basically, initially everything will be -1. As and when we will compute, we will replace this -1 with the correct value. So if it is not -1, we will not recompute this entire thing. We will just return whatever we have computed before. So now just to let you show this how number of employees available is changed. Before we are passing a vector, but now we are passing a mask. So what we have done is we have just checked whether the ith bit of this mask is set or not. If it is set, we will push it to the like we are again preparing the set of all the selected days. So this time we are checking whether the ith bit is set or not. If it is set, we will just push it to the uh, set to our set of selected days, and rest of the things are similar. So hope this solution is clear. Now let's look at let's just look at a particular follow up. So what we have is this D, R, and mask in our function. So if you just remember, we have these three things in our DP array. Okay. So now whenever you have more number of values in your DP array, just try to think if you can if you really need all those variables. So in this case we have these three variables. So always try to think if some variable is such that you can get the value of the variable directly without having the variable itself. For example, in this case we have this d mask and dr and mask. Now let's assume, so what, like what is the value, like given that mask is required, like you can't remove mask from the equation, because mask denotes the number of exact days that you have scheduled the course on. So this is required. Now which one of this can be derived from this mask? So mask actually denotes all the days, like basically mask has one in some of the places and rest of the places are set with 0. So now what you need to do is you need to think, if we don't, like what you can derive from mask. So let's say if we don't have r, if we don't have r basically denotes the number of repetitions left, right? So initially let's say the total repetitions was this. Now if you have this 3 bit set in your mask, it means that r will be equals to this minus 3, right? Because whenever you are adding something to the mask, you are also subtracting one from this total repetitions, right? So just to recap, previously whenever we are selecting something with mask, we are also removing this from our like we are also removing one from this repetitions left. Okay, so what exactly is happening, if one, like let's say if one more bit is set here, then we are sure that one more time this repetitions will be subtracted by one. So if initially the number of repetitions is r, and if number of bits set in this mask is b, then, like let's say initial number of repetitions is r dash and number of bit set in this mask is b, then r dash minus b would be our new r. So if you don't understand this, please watch the previous 2 minutes of the video. Just to summarize, what we are saying is we don't need R at all. We can derive R from this mask itself. So how we can derive R? We can derive because every time we are appending something to the mask, we are subtracting one from this repetitions left. So it indirectly means that if there are if there are b number of bits set in this mask, and initial number of repetitions are this r dash, then total r dash minus b will be the value of r at this current state. So if we don't have r at all, then also we can calculate r easily with the help of this total repetitions, which is constant, and the mask that we have in the function parameter already. So what we have done here is we have removed this r altogether from the question. So just to get over the pseudocode, what we have done now is we have removed this r from the equation, and what we are saying, we will compute r on the fly within the equation, and r will be total repetitions minus number of set bits in this mask. Okay, and now once we have r, the rest of the part is exactly similar. You can see whatever we are doing previously, we will do same thing again. So let's look at the code. I will strongly encourage you to pause the video here and try to code it yourself. In case you are not able to, please feel free to continue. So that's the code. What we have done here is we have just removed that repetitions from our equation, and repetitions left we are calculating inside it, which is total repetitions minus count of set bits in selected mask. So count of set bits is like basically we have pre-computed the count of set bits in all the possible value of selected day mask. So that's a different story. Basically, we are able to compute the repetitions left here. Now everything is exactly similar. One more thing, we now don't have to store this repetitions anymore in the DP array, because previously if you see this, that's what we are storing in the DP array, current day, repetitions left, and set day mask. But because now the parameter of the function itself is reduced, we have only two parameters. We have completely dropped the repetitions left from this DP equation, and that is significantly bringing down the complexity of this solution. So hope this approach is clear. Now let's quickly look at the space and time complexity of this solution. So what we have is current day and selected mask. So now let's say there are d days. Okay. So if there are d days, there will be d spaces, right? And every space will be either can be either 0 or can be either 1, right? So everything has two possibility, either they can be 0 or they can be 1. So total number of possible values of mask is 2 into 2 into 2 up till d times, right? So total number of possible values of mask is 2 to the power d. That's what the total possible values of selected day mask. Now, current day is basically the number of possible values of current day is d. So that's these many number of, like these are the number of states that we have, and inside each of this state we are doing some max operations or like plus minus operations. So that is constant. So that's the final time complexity of our solution. So if you remember, we had started with order of d factorial, and with simple observation that converting a vector to a mask, we are able to reduce this to 2 to the power of d into r, basically when we have three parameter in our function. Now with again a basic observation where we say that we don't require r at all, r can be calculated with the help of this mask itself. We have removed this r from our complexity, and that's the final complexity of our current solution. Now comes a twist. Let's solve another follow-up. So that's what we have been solving so far. That's the time complexity of and the space complexity of this solution. Now let's just solve an interesting part. Let's say E is less than D. Okay. So if E is less than D, do you think it is possible to reduce the time complexity here? And if so, how? So basically, currently we have 2 to the power of d into d, right? So do you think there is a way wherein we can replace this d to the power of 2 to the power of d with 2 to the power of e? Uh, like there is one way, and the way is very similar to what we have done. So basically, we when we reduce this 2 to the power of d into 2 to the power of e, then we can clearly see the time complexity will reduce drastically because e is smaller than d. Now comes in like whenever you see there are two variables. So if you remember, we had two variables in our equation, like total repetitions and total days, right? So whenever you see there are two variables and the complexity of a solution is something like 2 to the power of first variable into something else, there is always, almost always, a possibility wherein you can solve this in same exact thing with 2 to the power of the second variable in this case e, like number of employees. So into some factor. So that some factor is something else. So basically what I'm saying is whenever you see a problem with two variables involved and the complexity you are coming up with this 2 to the power of d into something, you can almost always solve the same question with the reversed exponential. So basically currently the exponential is d. We can solve the same question with 2 to the power of e. Now how to solve the question is again an exercise for you. I will link the solution, the code of 2 to the power of e part as well. But just to give you an hint, this is what will come handy. So let's just look at it clearly. So what we are saying is we will, like our new state will be something like this. So instead of saying previously, if you remember, we had this vector of int of selected days, but now we are saying vector of int of already available employees. So we have selected some days before, and this already available employees denotes list of employees who are who can already attend with previously selected list of days. So that's what this already available employees denote. Now what your what your dp stated, like what this will return is, this will state that how many maximum number of employees can attend the training, given that all the employees in this already available employees list have attended the training already, and there are more course schedules which are left, which can be scheduled over the next d days. So that's what the the state of our function is. If you think this is exactly similar to what we have for the days, like just previously we have days here, now we have employees here somehow. So basically previously we have just selected days, now we have to select for each, like let's say if you select d day, like again there will be two possibility, right? Either you will select the dth day or you will don't select the dth day. Now when you select the dth day, previously you are just appending this d to the vector, like the previous set of vector, you are just appending the d. So just to recap. So previously what you are doing is we are just appending this current day to the already selected list of vectors, right? So that's what you are doing previously. Now instead of appending this to the vector, you will see how many employees are available on day D, and then you will add all those employees to this vector. So just to show you the solution will look something like this. So basically, uh, as discussed, we will have a vector of employees. Like I have said, I have taken another set, but the solution will be very similar. So now, whenever you take something, let's say you take the current day. So if you take the current day, you will see whether like how many employees, like you will iterate over all the employees, and you will see how many employees are there who are available on this current day. Okay, so how many employees are there who are available on this current day? But if you remember, you don't have this vector, you have the vector which all days this employee is available on. So you have to prepare the reverse mapping first. So you have to prepare like this reverse mapping which will tell you how many employees are there are available on a particular day. Now once you have this, you will just append this to this employee set. So previously you are appending D, but now you will be appending all the employees who are available on that day D. And the rest of the things are very similar. So where you will just subtract one and pass the new employee set. And in the other case where we don't set the current day, you will just pass the previous employee set with the same number of repetitions. Now, when you have selected all the employees, like when you have scheduled the course for all the R days, you will just return the size of the employees, like this employees vector. Okay. Now, hope this part is clear. So again, we can go over like this. Like this is one part. Now we can't memorize it. Again, the same thing will come. You can convert this to an integer mask and reduce the time complexity, like memorize it to reduce the time complexity from e factorial to something else, or n factorial to something else. Okay, so that's the first part. And second part also, you can see we have three different variables here, right? So again, you can optimize that, and you can think of if you can remove something here. So it might not be possible to remove here, but it is a fun exercise to do. So I will encourage you to code both the part. The first part wherein you will convert this to a integer mask similar to what we have done previously, and second part wherein you will try to remove one of these instances if possible. I'm again saying it might not be possible, but it is a fun exercise to do it. If you want me to review any of your solutions, feel free to post them in the description section below. I will definitely review it and get back to you whether if there is any problem with your solution. So that's it for today. Hope you enjoyed the entire problem, the second problem. I will link the similar kind of discussion that we have for the first problem and other problems of Amazon and Facebook interviews in the description below. Do check them out, and I will come. We will meet again tomorrow with a new set of questions. If you like the video, please like and subscribe to the channel for getting updates of the future video. So goodbye.